Good afternoon. So last class, what we have seen over on it, Abdina, we have seen the what are all the components of robots. Okay. So we'll have a controller, variation, size and shape, sensors, and end effectors and tools. Okay. So today's what we are going to see about Abdina. We are going to see about last of robotics. Okay. So we all know that there is Isaac Asimov. Isaac Asimov. So he has framed or he has said that three laws of robotics. So I have given the thing that is survive, obey, protect. Okay. So this is the major thing that you can able to remember: survive, obey, and protect. Okay. So we can go with the last one states. What does it say, Sabina? So when we are defining any robot, when we are defining or when you are designing any robot, it may not injure a human being or through inaction or allow a human being to come to harm. So that is the thing first thing. Okay. So it has to be goes for with the robot may not injure a human being or through inaction or allow a human being to come to harm over that. And next, when you're going for law 2, okay, so it must obey the orders because that is the first thing, okay, which is given by the human being, okay, except where such orders would conflict with the first law. So, in the same thing, that it should not injure the human being, okay. So, the robot must obey the orders given it by the human being. That is the second law. And the third law is a robot must protect its own existence as long as such protection does not conflict with the first or second law. So it has to protect its own existence. Okay. But same time, it has to be obey the orders given by the human beings. Similarly, it should not injure the human being. So this is the things which has been defined by the Isaac Asimov's laws. Okay. And when we are saying about so these are the three laws which has to be constantly followed when we are designing a robots. Okay. The next we have to see about what are all the different types of joints for the robotics. Okay. So when we are saying about different types of joints, so we'll have 5 types of mechanical joints. So in the case of joints, actually it can able to provide the motions of the robotics. So we'll have a two different motion, one to be the translational motion and other one to be the rotary motion. Okay. In the different 5 types of joints, so what they have said that Abdina, among the 5, the 2 will be providing the translational motion, whereas the 3 will be providing the rotary motion. 2 will be providing translation and 3 will be providing rotary motion. Okay. So let me see what are all the joints available over on it. We'll have a linear joint, orthogonal joint, rotational joint, and a twisting joint, and finally we'll have a revolving joint. What are that? LORTV. You can remember that. What are the things? LORTV. Linear, orthogonal, rotational, twisting, revolving. Okay. So in among LORTV, whereas L and O will provide the translational motion. So in the thing that the input and output links will have over on it. So this can be made as a parallel or a perpendicular. If you are making it as a parallel, it go for a linear joint. If you are going for a so orthogonal, so that is go for a perpendicular. Okay. So these are the two different things I have shown in the diagram A and B. That is whereas the input link and output link which has been motion it has been linked with the given the parallel and perpendicular. Whereas in the case of a rotational joint, so the axis of rotation is perpendicular to the input and output. So rotary, we have to define the axis of rotation. Okay. So in the case of perpendicular Abhina, we can go for rotational joint. If it is a parallel Abhina, we can go for twisting joint. That is in the case of revolving வந்து பாத்தீங்க அப்படின்னா இன்புட்க்கு parallel இருக்கணும் அவுட்புட்க்கு perpendicular இருக்கும். So இந்த மாதிரி இருந்தது அப்படின்னா we can go for an revolving. Okay, what are all the different types of joints? We'll have a linear joint, orthogonal joint, rotational joint, twisting joint, and revolving joint. Okay, good. The next one, classifications of robots. So we'll have a Cartesian coordinate, we'll have a cylindrical coordinate, we'll have a spherical coordinate, we'll have a articulated coordinate, and we'll have a SCARA. SCARA explains for selective compliance assembly robot arm. Okay.